Hey guys, welcome to the fourth installment of the lecture series in Precalculus. Today we'll be talking all about linear equations. So a linear equation is something that looks something like this, where we would have something like 4x plus 2 is equal to 10. How you can tell an equation is a linear equation is that it contains one variable, so x in this case. That's a linear equation where there's one variable. Not to be confused with one occurrence of the variable. This is also a linear equation. Sorry, right there. That's also a linear equation. It shows up two times, but it's only x. There's no other variable. So this is linear. And a linear equation really represents the equation of a line. So if you have some kind of a graph, which we'll get into a lot soon, and it represents a line, this line will have an equation to be able to plot it on an XY graph. We'll talk all about that when we cover functions. But for now, let's talk about how to solve a linear equation. So what does it mean to solve a linear equation? So let's take this example per se of 4x plus 2. To solve a linear equation, what we're trying to do is find out what in the world is the value of x. Before we actually, we would substitute x in for 5 and just solve a left-hand side. But now we have an equivalence. This means the left-hand side, or the LHS left-hand side, is equal to the RHS, the right-hand side. So obviously we can't just plug in 5 because 4 times 5 is 20 and this is 22 and then this is not equal. So how do we figure it out? So one way to do it is via trial and error. So trial and error. Trial and error is probably the least inefficient way to do it, but it's a great place to start understanding. So if I want to figure out if this works, I could say we can plug in x equals 1. So if x is equal to 1, what do we get? If x is equal to 1, we get 4 times 1 plus 2 is equal to 10. This is 4 plus 2 is 6 is equal to 10. So this is wrong. So x can't be 1. And can x be 2? Let's try that. So 4, 2 plus 2 equals to 10. And you get 8 plus 2 is equal to 10. And 10 equals 10. So yeah, in this case, we actually did get it to be right. But imagine if you had to keep going up until 300,000, you wouldn't be able to do it. And it's not very efficient. So how do we solve a problem where we can figure out what x is? So this is called isolating the x. So to isolate a variable, you have to manipulate the left-hand side and the right-hand side such that x is by itself on one side of the equals. It can be on the left, it can be on the right, doesn't matter. Generally, it's convention to have it on the left-hand side. So how do we go about manipulating algebraic equations like this, or a linear equation? So all we have to do is get x by itself. Now, one of the most important things to remember is whatever you do to the left-hand side, you want to make sure you do to the right-hand side. I'm actually going to move this over slightly so you guys can see what's going on. Sometimes I lose track of where everything is on the camera. So now we see that 4x is together, but 2 is there by itself. So the first thing we can do is start removing numbers that aren't attached to the x or aren't part of the x. So what we could do is 4x plus 2 minus 2, that would get rid of the 2. So you just do the inverse operation. So if you're adding, you can minus. And then you have to make sure you do the same thing on the right-hand side. So now if we simplify this down, we just get 4x because the part here is 0, and we get 8. Now what? So now we have 4x. So how do we get rid of the 4? And the easiest way to remember is sort of the table of inverses. I'll draw a little table here of, so let's say the operation, wow, okay, operation, and then the inverse. And so if you have plus, the inverse is minus. If you have minus, the inverse is plus. If you have multiplication, the inverse is division. If you have division, the inverse is, you probably guessed it, multiplication. So whenever there's a multiplication, in this case 4 times x, you want to do the inverse. So you want to do x 4 times x divided by 4, and 8 divided by 4. And what's 4 x divided by 4? These two cancel out, and you get x, and 8 divided by 4 is 2, and there's your answer, exactly as we saw over here. So now let's try some slightly more involved answers, let's say, or involved examples. So I'm just going to take you through them, but once I write out the question, let's pause the video, and I want you to give them a try yourself and then check the answer. Because that's the best way to learn. The best way to learn math and most of the technical skills is just to do it. Just throw yourself in there, start doing the math. That's the only way you're going to get better. The more you do, the more patterns you'll recognize, the faster your brain will be able to pick it up. So take a pause, and then we'll start going. Okay, so hopefully you've paused, found your answer, and now you're going to check it with me. So order of operations, right? BEDMAS or PEMDAS or PEDMAS, it doesn't matter. But we're going to start with inside the bracket, which we see that there's nothing we can do. So we're going to use distributive law, and we're going to distribute it out. So we're going to do 8x minus 24 is equal to 16. And now, how do we get rid of this 24? We do what we did before, which is if there's a minus, we add. So we do 20 plus 24 to both sides, right? Plus 24 to both sides. So you're getting 8x by itself now equals 40. And there's a multiplication here, keeping the x together with the 8. So we have to divide. So if we divide this by 8, we get x. These two cancel out, and x is equal to 5. Easy peasy. It's pretty easy once you start getting the hang of it. Okay, let's move on to another example. So let's do 2x minus 4 plus 9 equals 15. Make sure you pause this and try it. So I'll give you a second to pause it. Whoops, I'm clicking random stuff. And so first thing, BEDMAS, brackets. There's brackets, but there's nothing you can do. Exponents, no exponents. Multiplication, there's multiplication. So let's simplify this down into 12 plus 9 equals 15. And then there's this. Let's simplify that down. Minus 3 equals 15. How do we get rid of 3? The inverse of 3. Minus 3 is plus 3, so we do that on each side. So minus 3 plus 3 plus 3. And so we get 6x equals 18. How do we get rid of the 6 here? We have to divide the whole thing by 6. And you get x, and you get 3. And that is the answer. So let's do another one. So now things start getting a little trickier. All right. So what if you run into a case that looks something like this? 4x minus 6 is equal to 2x plus 10. So now there's x's on both sides. So what does this mean? So we got to move all the x's to one side and all the non-x's to the other side. Right. So if they're attached to like terms means two x's, you can actually just add them together. So let's start by moving this 2x over to the left-hand side. So we want to subtract, since it's a plus 2 here technically, we want to move it to this side. What we have to do is 2x plus 10 minus 2x from each side. So 2x minus 6 minus 2x. So if we simplify this down, on the right-hand side is just 10. On the left-hand side, you're getting 4x minus 2x, which is just 2x minus 6. And now it's the usual routine. We've gotten all of the x's to one side. All we got to do is move this over. So to get minus x, you got a plus from both sides. So we'll do 16 and 2x, and then we divide as per usual. Divided by 2, and you get 8. Awesome. Let's do one more to make it easier on us. So example number 5. I'm not even sure if I used example before this, but that is what it is now. Plus 9 is equal to 6x minus 27. So pause and do this and come back. And hopefully you've done it. And let's rock and roll. So The quickest way to sort of think about this is since 3x is smaller than 6x on this side, let's move the 3x over. So let's do minus 3x plus 9 plus 3x, and then 6x minus 27 plus 3x. So now we have 9x, 6x plus 3x, 9x minus 27. And on this side, we'd have just 9. And now all we have to do is our usual shenanigans, and we got to move this over. So we go plus 27. Well, plus 27 on this side, and we get 36 on this side and 9x. And to get rid of the 9, we got to divide by 9. And these two will cancel, so you get x, and 36 over 9 is 4. So x is equal to 4. So you see those are occurrences of where you don't actually have to have it on the left-hand side. Sometimes the right-hand side might be easier. But at the end of the day, you're going to end up with the exact same solution. So let's make it slightly even more complicated. Let me get rid of this right here. We don't need this right now. And let's do one last example to make sure we drill this home. So let's try example number 4, and we'll do 3 times 4x minus 5 minus 4 times 2x plus 1 is equal to 5. So where do we start? Well, we start with BEDMAS. So brackets, seems like leftmost bracket makes the most sense, and multiplication, right? So we gotta multiply this stuff out, we gotta multiply this stuff out. So 3 times 4x is 12x minus 15 minus 8x minus 4 equals 5. Yeah, do let me know in the comments if you'd like me to slow down a little bit, but if the pace is good for you guys, I'm going to continue going at this speed. So let's combine like terms now. So 12x minus 8x minus 15 minus 4 equals 5. So let's combine these two together. That's 4x minus 19 is equal to 5. And now we got to get rid of the 19. So what do? We add them to both sides. So we go 4x minus 19 plus 19 equals 5 plus 19. We get 24 on this side, and we get 4x on this side. And we just divide by 4, and we get x is equal to 6. Hopefully that was a good, concise little refresher on how to manipulate things. Remember, summary, there's 3 things. One, let me write this down, make sure you guys have this written down. So, whoa, went too far. Okay, so 1 is you want to isolate for x. Isolate for x. That's the number 1 thing that you're trying to achieve. That's kind of the goal. And to achieve this goal, what you do is first simplify the equation. Simplify the equation, and then manipulate by operating on both sides. And if you can do these 2 things, you can solve for any equation. Eventually, you'll start working up to equations where you have multiple variables and you want to solve for those, and that's when it gets really fun. So for now, make sure you understand this fundamentals. If you don't understand this, it's really hard to get into the fun stuff and learn about how to apply it. The application part is hard to teach without knowing the fundamentals first. That's why we go through as many practice problems as we can, learn it as well as we can, so that when we do get to the application and you'll be like, aha, this is what it's used for. When we get to that part, you're really good at math, you're really good to go. So I hope you guys enjoyed this video, and if you learned something, please like it, subscribe, share, and I'd love to hear your thoughts in the comments. And that's it for now. I'll catch you guys in the next one.